Welcome all the participants. All the participants, please join the webinar with your registered name.
Good morning, everyone, to this beautiful and wonderful morning. Hope all of you are good and healthy. Welcome to the webinar on emerging trends in geotechnical engineering conducted by Civil Engineering Department of SMS, Bivrabai Sawant College of Engineering and Research, Nare, Pune, coordination with Indian Geotechnical Society Chapter, Pune. My name is Pooja Shamrao Kondalkar, studying in third year of Civil Engineering. I would like to welcome our honorable chief guests, dignitaries, and participants. We will start our program with Saraswati Vandana.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणा पुस्तकधारिणीम् अभयदा जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Now I will hand over the session to President of IGS Student Chapter, Mr. Jayesh Kolle.
Good morning to all the respected dignitaries and participants. My name is Jayesh Kolle, President of IGS Student Chapter, Pune. We all are very delighted to welcome all the dignitaries in this webinar session. We welcome Engineer Vikas Patil Sir, Chairman of IGS Pune Chapter. Engineer Annapurni Iyer Madam, Joint Secretary of IGS Pune. Professor Suman Jain Madam, Secretary of IGS Pune. Engineer Shahnawaz Mulani Sir, guest speaker of this session. Dr. G. Hinge Sir, Principal of Bivrabai Sawant College of Engineering and Research Pune. Dr. R.S. Karale Sir, HOD of Civil Department. Professor K.S. Bosle Madam, Faculty Advisor. On behalf of everyone, we all welcome to this webinar session on emerging trends in geotechnical engineering, organized by Civil Engineering Department in association with IGS Pune chapter. We also thank to IGS Pune for giving us this opportunity. The Indian Geotechnical Society is a platform for the researchers, designers, construction engineers, civil engineer students, and manufacturers to gain more knowledge in the field of soil mechanics. IGS aims to encourage the cooperation among all the engineers and researchers for the advancement of knowledge in the field of geotechnical engineering, and it also serves as a link between students and industries for knowledge increment in form of webinar and case studies. These are different glimpses of activities under the IGS student chapter. Guest lecture by Engineer Vikas Patil Sir. Session by Professor V.R. Fadke and Professor Mrs. V.U. Khanapure. Session by Professor M.S. S.R. God. Activities under student chapter. Industrial visit to site investigation and soil exploration, visit to substructure construction site at Nare, visit to construction of foundation of TSSM BSCOER Girls Hostel, Nare, Pune. Thank you.
Thank you, Jayesh. It is my pleasure to invite Engineer Annapurni Iyer Ma'am, Joint Secretary of IGS Pune Chapter.
Good morning, everybody. So today on 4th March 2022, we all assemble here for yet another student chapter activity. So on behalf of IGS Pune chapter, so I wish to welcome the management of college, TSSM, BSCOER, College of Engineering Pune, principal sir, campus director sir, HOD civil, and all the faculty members and the office bearers of IGS student chapter of this college. Welcome to this event. I also extend my welcome to IGS main body members who are here. We have AP Singh sir with us. We have extended our invitation to IGS President Samadhya sir also. So he may join towards the end of the event. Welcome to IGS Pune chapter office bearers. We have Vikas Patil sir, myself. We have other executive committee members. Welcome to each and everyone. And of course, speaker of the day, Shahnawaz, whom I know for a long time. Welcome to all the students, faculty members of other student chapters who have taken time and are attending this event. We have more than 237 participants, and on a working day, it's really commendable. So great efforts by the college faculties who have taken this initiative of organizing this event. So student chapter, as we have seen, the main objective is to provide a strong platform for the students for performing, as well as enhancing their skills for a seamless transition from their academics to profession. Okay. So please use this platform as much as possible. We will also try to bring different activities in this platform. So expert lecture is one activity. Apart from that, we should also look at organizing other activities also, like quiz competition, debate competition. It could be discussion of various good projects that are happening in and around Pune itself. Metro work is going on. So let us also look at organizing other activities. So full appreciation for organizing this event. And apart from this, we also look forward for the faculty development programs also through these activities. So I'm sure with the discussion of the emerging trends, topics like emerging trends in geotechnical engineering and frequent visits to the sites and other activities, faculty development also will happen automatically, which will again penetrate to the students. So IGS Pune chapter look forward for all the support to the student chapter and development of the student chapter. So without wasting much time, I stop here and welcome one and all for this event, and best wishes to Shahnawaz for his lecture. Thank you.
Thank you, ma'am.
Thank you, ma'am. Surely we will try our best to fulfill the main objective of IGS.
To the all participants, if you have any questions, you can put in the chat box, which will be answered at the end of the session. Thank you.
Now I request Engineer Vikas Patil sir, Chairman of IGS Pune chapter, to share his thoughts.
Good morning to one and all. So right at the outset, let me thank first of all the management of JSPM Campus Director Rushraj Sawant sir, then Dr. Hinge sir, Principal, Dr. Karale, HOD, Professor Kirti Bhosle, Staff Coordinator, and Jayesh Kolle, who is in charge of IGS student chapter at JSPM campus, Nare.
Thank you, sir.
So, first of all, let me acknowledge that this Sumoto initiative taken by your institute. No doubt, Dr. India must have really inspired you all, and that I'm sure. But this is a Sumoto initiative taken by you people is highly appreciated by IGS Pune chapter. On behalf of IGS Pune chapter, and thanks to one and all that those who have taken the initiative for this event as such. Secondly, about Shahnawaz sir, the topic itself speaks loudly that emerging trends. And yes, we want the youngsters, young geotechnical professionals to come forward, share their views, share their knowledge, and let the people to get inspired, let youngsters to get inspired. And this is our motto. And with that, we are trying our level best. As you all know that IGS Pune chapter is committed to have excellence in the field. Yes, we are trying to lead ourselves in a way that there should not be any datum. We have decided that we'll set our own datum. We'll set our own datum, actually will work. And in that, we'll say that in the coming next week, we are having a mega event, that signature event of the IGS Pune chapter. And that we are felicitating two stalwarts, two seniors, Professor Vijay Kasmarkar and Engineer V.V. Abbenkar, who are the mentors of IGS Pune chapter years together. And in the honor of these two stalwarts, those who have crossed their 90s, we organized one day technical session that is on 11th of March in Hotel Sheraton. So I invite one and all to just participate in that event and see that in what way we are cultured. This initiative is taken by Professor, our past chairman, Engineer Ramesh Pune sir. It was his idea, and we all are working very hard to make it exclusive one. So anyway, for today's session, I once again congratulate the entire team, that IGS student chapter team, all members, and no doubt Professor Dr. Hinge sir, I really strongly acknowledge this initiative, because this is the first event of the year 2022 where the institute of their own have taken the initiative, and they are organizing such an excellent event, as excellent sessions. So once again, congratulations to one and all, and I'm really grateful. Shahnawaz sir, we on behalf of IGS Pune chapter, we strongly acknowledge your participation, your involvement in the session, so that the youngsters will get inspired. So we really strongly acknowledge your participation also, and thanks to one and all. Thank you.
Thank you, sir. Sir, I wanted to make sure mainly will be based on the practical things, what as a geotechnical engineer I am doing in the industry. So mostly I will be highlighting those things rather than the theoretical point of view. That point I will take care, sir, in the presentation.
Great.
Thank you, sir, for your appreciation, also for sharing about IGS mega event and try to participate. Now let me invite Ms. Sampada Nanasaheb Rakte, IGS Secretary, Bhurabai Sawant College of Engineering and Research Chapter, Nhare, Pune.
Thank you, Pooja. Good morning, everyone. My name is Sampada Nanasaheb Rakte, studying in third year of civil engineering. I introduce our today's guest, Engineer Shahnawaz Mulani. He is currently working Assistant Geotechnical Engineer at Jacobs. He has an experience of more than 7 years in field of civil engineering as a geotechnical engineer. He has worked in Dar Consultant Private Limited, which is one of the leading consultancies specializing in architecture, planning, engineering, as well as project management and economics as an geothermal engineer. He has made many contributions towards the field of civil engineering. He has worked in many big projects on national and international level. I would like to mention about few projects he has worked on. Mohammed bin Rashid Stadium, which is located in Dubai. It is a stadium with 10,000 seating capacity. Star Ryan Farm Project Quarter, the international humanitarian city also located in Dubai. Jebel Ali Residential Community Infrastructure and Community, Dubai, and many more projects in Dubai. He has also worked on beautiful piece of art located in Mumbai, that is Warsaw Bandra Sea Link. He has worked on the design of deep foundation of bridge with many other things. He is worked with pre-bid engineer consultancy services for coastal road project in South Mumbai. Proposal for Bandra Warsaw Sea Link project. 2 times he worked with the proposal from McAfee Environmental Solution Private Limited in India. I would like again welcome this dynamic personality. Thank you.
Thank you, Sampada, for your loving words. Now I request today's guest, Engineer Shahnawaz Mulani, sir to start his session.
Thank you all. First of all, very good morning to one and all, especially my friend Mr. Chaitanya Shetgar, who encouraged me to give this, to attend this session, because I was very much busy with my design activities in the Jacobs. I could not found the time to have some time for this presentation, but he encouraged me a lot to give the presentation. I would like to present my sincere thanks to Annapurni Iyer ma'am, who is my colleague, and she knows me, I think, since last 8.5 years. I would like to express my sincere thanks to Vikas Patil sir and other dignitaries and all the students and office bearers who are organized this session. Thank you all. Let me start with the presentation. First, I would like to present my sincere apology because I could not start my video. I'm using my personal laptop. I could not use my office laptop, so the camera quality is not that much good. So I'm just keeping video off. So first, let us start with the presentation. Today's topic of the presentation is recent trends in geotechnical engineering. The content I will be covering in this presentation, the brief introduction about me, about myself, the brief about the geotechnical engineering, what is geotechnical engineering, the subsurface investigation, which is the backbone of geotechnical engineering field, what are the different geotechnical applications which we normally used, which are demanding in the current field of the design or industry, what are the softwares that are available in the field of geotechnical engineering, what is the role of a geotechnical engineer, let's say it may be a consultant side or at the contractor side, what the consultant, what the company or what contractor expect from a geotechnical engineer, that we will have some look on this also. And there will be a short video on the coastal road project which I'm working on at present in the Jacobs, and that is also available on the YouTube. Just a minute. Yep. First, let me start with my brief introduction. As one of the colleague presented my brief introduction, and just I would like to highlight a few of the points apart from her introduction. I completed my MTech in Geotechnical Engineering from College of Engineering, Pune in 2014. And after completing that, I joined McAfee Environmental Solutions. I worked there for 2 years from 2014 to 2016. Mainly, I dealt with, when I was in McAfee, I dealt with geosynthetic products and its application. Basic applications were the basal reinforcement, reinforced soil walls, reinforced soil slopes, the design of reinforced pavement, the drainage solution, lining application, etc. And I was also part of the team which was designing the double twisted wire mesh products. I think that was the Gabion walls, the reinforced soil walls, reinforced soil slopes. I think Dr. Ratnakar or Annapurni Iyer ma'am has conducted many of the presentation on this field. So we will be having some brief, but we will not go into the detail of all these application and products. After that, in 2016, I joined Dar Al Hansa, which is one of the pioneer engineering consultant in the field of civil engineering. There I spent around 5.5 years till to December 2021. And fortunately, Dar was my, let's say, the main foundation company which give me a lot of responsibilities, lot of opportunities to express myself. There I fortunately worked on one of the India's biggest landmark project, that is Warsaw Bandra ceiling project. There I was part of that project from the inception. I think that was the pre-bid stage. From pre-bid stage, we were involved in the as a designer for that project. I was the project engineer from the geotechnical department for that project in the pre-bid stage, as well as after awarding the contract to Reliance Infra. Mainly I used to do the following activities when I was in Dar Al Hansa: the planning subsurface investigation program, the preparation of the geotechnical interpretative reports, reviewing the factual reports which we receive from the SI contractors, design of shallow foundation, design of deep foundation, which are pile design, and the slope stability for few of the cases, the pavement design and shoring system, etc. Then in December 2021, I joined Jacobs, and currently I'm working as a senior assistant engineer in the Jacobs. Jacobs is one of the leading pioneer in the field of geotechnical engineering, which is US based MNC. Now let us start with our main presentation. We will have some, this slide is presenting what is the geotechnical engineering. From my point of view, geotechnical engineering is nothing but is the study of behavior of soils under the influence of loading and the soil water interactions. Because whatever structures mainly we construct, we see that is building, bridges, any of the structure, dams, or let may be the infrastructure, roads, pavements, all those are resting on the soil. Whenever any structures comes in the contact with the soil, we are part of that structural design, or let's say the foundation design, or maybe there may be a wall, retaining wall application, something like that. Whenever any structures comes in the contact with the soil, we are there for helping to other departments. Basically, see, you might considering the diploma, the audience which is attending the presentation, the diploma holders and the engineering B or third year of final year engineering students. Mainly I'm going to present from practical point of view, not the theoretical point of view, considering the students. So mainly where geotechnical engineering knowledge is required. We are there for design of foundations. Whenever there is a retaining wall, we are part of the design of the retaining wall. It may be the concrete retaining wall, gravity retaining wall, or let may be MSC, mechanically stabilized retaining walls, reinforced soil walls, reinforced soil slopes, anything. Earthen dams or liners or geosynthetics for waste containment. In all those category, we are part of the geotechnical, we are part of the design team. So considering the soil which we are mainly dealing, I have presented a small table in this presentation slide, which states or differentiate or present different soils. For example, gravel, sand, silt and clays, and high organic soil. I have put this slide intentionally because, see, I wanted to highlight that even though we are telling the sand is good, gravel is good, silt and clays are problematic soils from designer point of view, but in reality, it is not the condition. For example, sands also impose many problems while designing the structure. If let's say there is sandy silt with less SPT value, then there may be the liquefaction problems that cause any tremendous problem while designing the structure. And clays, if we go to the clays, then there may be the consolidation settlement problem. If there is a water table present there, then it will impose higher settlement, which is not allowed by the codes for the design of foundation. These are the main soil types. Apart from that, we have the cobbles and boulders and rocks, all the category that will be part of the geotechnical engineering. Now let's move to the next slide. Can you see my next slide, ma'am?
Why
This one only. Why geotechnical engineering is different from other disciplines? This is a small slide which I have presented so as to give an idea what is the basic difference between the other engineering fields and what is the difference between the geotechnical engineering field. If we compare the structural engineering field with the geotechnical engineering, the first point here, it states material parameters are well defined and controlled. for example, steel and concrete. Many of you have done the designing of the building elements, for example, beams, foundation, columns, slabs. There you might have taken standard grade of concrete, let's say M10, M20, M30. That, if let's say we define M30, then that the characteristic strength of the concrete is has to be 30 MPa. That we already know from the beginning. If we go to steel, then we know what is the ultimate yield strength of Fe 250, Fe 500, Fe 550. But whereas we go to geotechnical engineering, each site condition is different. Material parameters are within few material parameters vary within few meters. For example, here I have listed different soils: gravel, sand, silt and clays, rocks, other things. So if let's say I'm standing here, if I do the borehole, we may get certain stratigraphy. Let's say at the top we may encounter 2 or 3 meter sand, then below that we may be having some clay, and below that at certain depth we may get the rock. But if I move, let's say 10 meters to other side, then it may not be the same case. We may have clay at the top, sand at the below, and we may not encounter the rock. That is the geotechnical engineering. We are totally it's the materials are not fixed. Each site condition is different. Material parameters vary within few meters. The second, the material models, the stress versus strain are well defined. If we see the stress strain graph of Fe 250 mild steel, then it is a standard. There will be some linear portion at the beginning. At the peak there may be a yield stress, and below that there will be a failure, and there may be drop in the stress strain graph. But whereas in case of geotechnical engineering, doesn't possess unique or linear stress strain relationship. That means that linearity may not be there in case of soils or rocks. To be defined, it has to be defined that stress strain relationship has to be defined case by case basis and function of different type, which is the function of the different types of soil and its basic mineralogy. The next point, the presence of water table has no effect on strength properties of the material. For example, concrete. If on the other side there is a water table, then it may not impact the design of the concrete structures. But whereas if we move to geotechnical engineering, changes the strength characteristic of soil significantly. For example, if we go to clay, we may encounter soft to stiff soil. There may be liquefaction potential in the sand. And if we move to the rock, there may be weaker rocks or stronger rocks. That kind of variability is there. And water is the main, I would say, the parameter which affects the design of the foundation structure. I want to remind one of the incident that took place, I think 3 or 3.5 years back in Pune. When I was staying in the Kondwa, I think there was one incident in the rainy season. There was a wall collapse happened during the rainy season, and I think one of the family got passed away in that incident. That was mainly because of the passing of the water and exerting the extra pressure on the retaining wall. That water can do. That is the part of geotechnical engineering. As a geotechnical engineer, we need to be very much cautious when water table is there. Let it be the walls or foundation, any structure. We must be very much cautious while designing the any of the structure when water table is there. The next, the effect of environmental stresses, wind, temperature, exposure to moisture can be accounted in the design. There are certain factors, let's say factor of safety is given, defined by different codes, for let's say wind factors, moisture is there, that different certain factors can be taken into account while designing the structures. But in case of geotechnical engineering, it's not like that. We may face, for example, if we consider the clay properties, it has, when water is added and when there is no water, then we may find the swelling and shrinkage problem that is very much unpredictable. The next point, the tensile loading can be accommodated in the design. As we know, the steel is very much stronger, very strong in the tensile capacity, and sometimes concrete also can take some tensile load also. But in case of soil, if there is any let's say tension, then soil cannot take any tension. If any tension load is applied, then we may find a failure of the soil. Soils are very good. Soil and rock are mainly the compressible material. The next point, the structural response is independent of stress path. That is too much technical. I will just go through this point. Soil response depends on the stress strain path. That is the normally if we go for the clay, then there are two categories we may find: the normally consolidated clay and over consolidated clay. The behavior of these two different stress path may be different. The next point, increase in volume under shear is not characteristic of structure. Soil dilates under shearing. And if we go for the cyclic stress strain behavior in case of structural, it is well defined for each and every material, for example concrete and steel. But in case of the soil, the geotechnical, the cyclic stress strain behavior vary according to different soil categories. It may be different for sand, it may be different for clay, or it may be different for rock. That is, this table gives an idea of what is the unpredictability we have in the field of geotechnical engineering. As a geotechnical engineer or as a geotechnical design engineer, you must consider all these factors while designing the any of the structure. This comes the considering all these factors need more practical knowledge or more experience. Even at my position, I cannot consider all these factors. I need to ask my senior, both those who are experienced. I need to consult with them, because it comes with the experience. As you worked in the field of geotechnical engineering, these points will get into your knowledge as you pass, as you gain some knowledge. To summarize this comparison, I can say we cannot see the geology, or let's say what is beneath the ground, that we cannot see completely, because whatever we can see, it's just a borehole. Whatever borehole data we are getting by drilling into the ground, let it be 100 meters, 200 meter, or 50 meter, that 100 mm 150 mm diameter borehole cannot give a complete idea of the underground stratigraphy. Which is that borehole is that if we do, let's say, 100 boreholes at a plot, if we compare the area of that borehole, total overall boreholes, it may be less than 0.01% of whole volume of the site. That is that kind of investigation we are doing. So you can understand, seeing this percentage less than 0.01, so how much we must be cautious while designing the structures as a geotechnical engineering. The Euro Code 1997 one defines that many geotechnical parameters are not true constants, but depends on stress level and mode of deformation. As I stated in the above table, that most of the geotechnical parameters are not having the same properties. If I say, I'm sitting in Solapur here, if I find, let's say, sand, that sand properties, the geotechnical properties of that sand may not be similar to the sand which we have in Pune. That kind of unpredictability is there. So that is there in the field of geotechnical engineering. Now let's move to the backbone of the subsurface investigation. Now here I have presented two pictures. The person who is drilling, doing the borehole, and here the below is barge, I think, which is standing, or which is doing the subsurface investigation in the sea. I think this is the picture for one of the project in Mumbai. It may be the coastal road, or I think Versova Bandra Ceiling project. Here I would like to highlight that geotechnical field is very old field. It has evaluated very much. If I say, if I compare two of the projects which I am working on, the Versova Bandra Ceiling project and the coastal road project. Both are situated inside the sea. The Warsaw Mandra Sea Link is around 1 kilometer inside the sea. There we did around 1,000 more, around approximately 1,100 boreholes into the deep sea, that the depth of investigation was varying from 20 to 50 meters. That kind of investigation we did. So you can imagine how much the geotechnical field has evolved, where we have reached. We can for investigation, there are number of companies. If I recall, the international companies like Fugro, SCTS, SAS. Fugro is there in India also. There, if I compare the Indian geotechnical investigation contractors, DBM, Renuka, there are number of contractors in India who are doing the investigation. So here I would like to highlight that it's not at all not, we can say, not non-achievable, or everything is achievable in the field of geotechnical engineering nowadays. Whether it may be any of the mountain, there we can do site investigation, the sea, coastal area, land, marine. Or I would like to highlight that I think Kavita ma'am knows very well about this. In the Warsaw area, I think there are some trees, or there are some coastal
Mangroves are there.
yeah, mangroves are there. So there also we did the investigation. So we can say there is no place where we cannot do the investigation. Now the field is evolved such much that we can access any site, we can perform site investigation, we can get the stratigraphy borehole data from any of the site. Here you can see the different types of coring cutters which are used for drilling the activities. The Here we have single tube, swivel tube, double swivel tube, triple swivel core barrel, and like that. So these are the barrels which from which we can get very good quality of samples. Here, if you see, these are after drilling the borehole, the sample is collected and kept in the core box form. This is the core box, typical core box photo I have presented over here. If you see this top portion which is wrapped in the plastic, it's basically soil. So for soil, we need to collect the samples, we need to wrap it, wax it, so that it has to maintain the natural condition. And below that, we found that these are the rocks, typical rock samples which we got from the drilling. So these are covered with these samples. Soil and rock samples are collected and kept in the core box photos, which is transported then to the field, the lab. There in lab also, the laboratory testing is evolved too much. It's not like that we may not get any parameter from the laboratory geotechnical design point of view. Here most of the parameters which are required from the geotechnical point of view, we are getting from the laboratory only. Now the laboratory are evolved so much that they can test any type of sample, any type of rock. They can any strength. Let's say if I compare the basalt, it has very huge compressive strength. That also we can determine from the lab. The next slide will be highlighting what type of testing we are doing. There are mainly two types of testing: the field testing, which is done on the site, and the laboratory testing. After collecting the samples in the core box photos, we take we take that samples to the laboratory, and there we do certain kind of testing. Here some of the I listed some of the tests in the field as well as the laboratory testing. These are mainly required from the design point of view. There are n number of tests we can perform in the field as well as the laboratory, but here I've listed only the parameters which are required from the design point of view. For example, if I check the field testing, there the soil boring. Imagine there is a stratigraphy, there is a field, we are doing the some excavation, some borehole. This is at the top, we may get the soil, sand, we may get the clay below that, and below that we may get the for the soil we may have some different kind of core barrel, different kind of sample. For the rock drilling into the rock, we may need some good quality core drilling equipment. That can also be done. Field permeability test, that can also be done to determine the permeability characteristic. Percolation test, the pressure meter test. The pressure meter test is mainly conducted for determining the modulus of elasticity of the soil or rock. Electrical resistivity, electrical parameters of soil, underground characteristic. The geophysical testing to determine the what is beneath the earth. Let's say if we want to determine the dynamic properties of the soil, shear wave velocity and other thing, that geophysical testing can be done to determine those parameters. The static or dynamic cone penetration test, that can also be conducted in the field. This is mainly required for designing the foundation. There are some equation which are based on the DCPT value, cone penetration value, for the design of bearing foundation. The test pits, let's say we can excavate a 3 by 3 meter test pit to, let's say, 1.5 meter depth. Take the sample, collect the sample, go it take it to the laboratory and conduct few testing. That can also be done. The field California, the CBR test, this is mainly required for the design of pavement. That can also be done at the field. The groundwater monitoring, as stated in this earlier slide, that we need to be very much cautious with the groundwater table. If there is we should be knowing what is the level of groundwater at that site, because your geotechnical design is mostly table only. So we as a geotechnical engineer, we should know what is the groundwater present at the site. That can also be done by using the field testing, that is the borehole log. Apart from that, there are additional testing which are highlighted in the bold. The pile load test, mainly these are conducted on the actual piles. There may be the vertical pile load test, the lateral pile load test, or maybe the uplift pile load test. That can also be done. I will explain in brief the pile load test in next few slides. Then the plate load test, as many of you know what is the plate load test. It's basically small size footing or big size plates, sorry, plates, steel plates, or maybe in some cases, if the foundation is of higher size, raft is there, let's say 50-meter 60-meter raft is there, then we may go for actual casted concrete block, where it may be pre-stressed or the normal RCC concrete block. That can also be tested using the plate load test. The piezometer test is mainly used to monitor the groundwater activities in the borehole. Now moving to laboratory testing, these are mainly the highlighted. I have just listed the main laboratory testing parameters which we need as a designer. It starts with the moisture content of the soil. What is the moisture content in the field? The Atterbuck's limit, the liquid limit, plastic limit, and shrinkage limit for a clay material, specific gravity of soil or rock. The shear test, shear box test, I can say, which is mainly required for determining the C and phi of the soil. This is mainly required for the design of foundation. Then grain size analysis, as in this slide I have presented the table, which is this your sand, the soil type is mainly dependent on your grain size analysis. So that also we perform in the laboratory test. The triaxial test, similar to the shear test, we can perform the triaxial test to determine the C and phi of the soil rock also. And here we may also get the modulus of elasticity from the triaxial test also. If there is any clay to, let's say, greater than 5 meters, 6 meter, 3 meter, 10 meters of the clay, then we know that it will consolidate if water table is there at the top or somewhere in the middle of the clay layer. Then we should be in position to understand what is the consolidation parameters, because your consolidation settlement will be dependent mostly on the consolidation parameters. That can also be determined in the laboratory testing. The free swell index in case of clay, the standard Proctor test, for determining your the bulk or the dry density, the chemical analysis of soil, rock, water. This is main because your structure, let's say if I consider the foundation of any structure, let it be wall, anything, the building foundation, bridge foundation, piles may be there, something, any kind of foundation which is buried in the soil, then there may be chances their soil is contaminated with some of the chemicals. There may be water, industrial water which is chemically active, that may be there, that may be the case. So that concrete properties are mainly dependent on your chemical parameters of soil, rock, and water. So as a designer, structural designer or geotechnical engineer, you should know what are the chemical properties of your soil, rock, or water. Then it comes the porosity and density of rock, that can also be tested in the laboratory. The in case of rock, what is the water absorption, the UCS test on rock, that is unconfined compressive strength on test on rock. This is one of the key parameter, key test I can say, which is done on the rock. Because if you encounter a rock, let it be any type of rock, this is the main parameter which is used in the design of, let's say, shallow foundation or pile foundation or any other slope stability analysis, any structure. That is the main parameters for the rock. Then apart from the UCS value, we can also determine the point load index test on the rock, then the modulus of elasticity of the rock. See, here I would like to reiterate that these are the main parameters which we require as a designer while designing any of the structure. There are other tests also which are not required from the design point of view, that may be required from other geotechnical point of view, but here are the main parameters which we require from a designer point of view. Now moving to the next slide, what are the different geotechnical applications? So as I stated earlier, every structure which is in contact with the soil will be dealt by the geotechnical engineer. Let it be rail bridges or road bridges or metros, as highlighted by Annapurni here, ma'am, that Pune metro. If you might have visited the site or have seen any of the construction activities which are going on in the Pune, you might have seen there is a pile drilled in the ground, and that pile, that then above that there is a pier, and there will be a deck for the metro. So that pile, design of pile is mainly done by geotechnical engineer. The advanced facilities, the oil and gas, if oil and gas, you know, there are onshore some buildings may be there, offshore structures may be there. If those that can be dealt by the geotechnical engineer. Buildings, we know the foundation that has to be designed by the geotechnical engineer. There might be some other elements also, walls also, there also we take a part. The aviation, I think during my introduction, I think one of your colleague highlighted that I worked on Al Maktoum International Airport. This is the aviation only. In airport, you may have number of structure, terminal building, ATR, ATCs and ATC building, other structures. All those structures can also need to be designed by the geotechnical engineer. Defense structures, marine structures, for example, if I go for the bridges, Warsaw Bandra ceiling, the coastal road, the marine structures, we are the key members of the design team. Renewable energy, for example, wind or solar structure, that the foundation of that structure is also done by the geotechnical engineer. Now let us go into the detail of what are the different applications. Here, if I see this left hand slide, here is the conventional, we can say, the shallow foundation. Here it's a building, it's supported by a shallow foundation. This shallow foundation has to be designed by the geotechnical engineer. If you see the below structure, there are number of footings, you can see shallow footings here, here. What is the new trend in this? If I consider any B graduate engineer, he knows that there will be a shallow footing of L by B size. Then we can determine the what will be the bearing capacity shallow foundation, and we can calculate the settlement. Let's say immediate settlement, maybe consolidation settlement of a individual footing. But in reality, it's not like that. Here, if you see these footing which are located around each other, for example, this footing, there may be a distance of, let's say, 2 meter 3 meter in between them. So there might, if I consider this footing, there might be influence of these two footings, this footing, that has to be considered in the design, which if I go conventionally by hand calculation, it's not at all possible for me to consider the influence of that footing. So here in the industry, there are tools, for example, the Settle 3 software, that can consider the effect of all individual footings. I would like to highlight one point here, that in MBR Stadium, Mohammed bin Rashid Stadium, Dubai, I had model around 200 to 275 footings in one software. So that software consider the effect of all those 275 footings on each other. Then that settlement, because of that influence of the other footings, that can also be calculated by using the software which are available in the industry. The next is the deep foundation. As we know, if there is a weak soil, then either we can go for ground improvement, or if or pile foundation, to have raised the pile on the wood strata to get the contribution from the weak soil as well as the tip resistance also. There might be different types of piles, the board cast in situ pile, driving pile, and other thing, number of piles may be there. So what is the new in the pile foundation that I would like to highlight? See, these are the main, you can say the shallow foundation is basic part. You consider any building, you may design the shallow foundation, let's say 10 meters, 8-meter story. If there is a good quality soil conditions prevails, then we can go for shallow foundation or raw foundation. But in case if there are weak soils which are not in position to support your shallow foundation, then in that case we may go for the pile foundation. So if I consider, these are the few the examples where the pile foundations are mainly used. For example, the bridges, bridge foundation, here the piers, below that in the ground there will be a pile supporting these piers and the deck. Here one of the typical example, which is being, the pile is being installed in the ground. There are mainly here is a pile, group of piles supported by a column or pier. There will be a pier cap, and above that there will be a pier or maybe column. For buildings, for bridges, there will be a pier. So now if I move to the next slide, here you may find, here you can see there are n number of piles supporting a pier. We can say this pier or this pier. There are six number of piles which are supporting a pier. Now what is the new trend which is going on? See, this is a individual pile having a bigger diameter, which is running from this here. If you see this the bottom image, here you can see 1 2 3 4 5 6. This is the construction activity which is highlighted in the graphical image. Here you can see this is the pile which is coming up from the ground and going up to the deck bottom, which is called as the monopile, which is also called as the single pile foundation. Instead of these n number of piles, nowadays the trend is going on that you can replace that n number of piles with a single pile having, let's say, 2.5-meter diameter pile, 3.2-meter diameter pile. These are mainly because if I go for the coastal road project, this is one of the image of ongoing coastal road project. This is the Haji Ali, and this is the Haji Ali connector. Here, if you see, these are the piers. These are, I can say, instead of pier, these are the monopiles, which are supporting this deck. These are the single pile which are supporting the deck. So this is the new trend which is going on in the field of geotechnical engineering. This monopile requires very much design carefulness while designing, because there are n number of we can say n number of unknown things in the design, because here you are considering your deck load will be, bridge load will be transferred to the single pile. Then it has to be very much conservative design that we are doing in the industry. This is the coastal road, typical layout of the coastal road project. This is the new trend. The next slide here, as I stated in one of the slide, I will brief some details about the pilot test. If I refer to this left side image, this is our conventional pilot test. We can say there is a frame, there is a anchorage, and here the pile, the load is being transferred from this loading system to the piles, and the loading is monitored with the data acquisition system. This is if I replace this frame with a building, this frame is you can say simulating your building load. Here the building will be there, and this pile will be subjected to that vertical loading. And this type of conventional pile load test simulates your actual the loading condition. The load is applied from the top, and it will go to the bottom from skin friction and through the end bearing. Now, what is the new thing in case of the pile load test? The new thing is the bidirectional load test cell. Here you can see this is a typical, we can say, graphical format. Here you can see, instead of applying the load at the top, if I compare the marine condition, for example this one, which let us assume this pier, this pile is around 1 meter inside the sea, in 1 kilometer from the your seashore. Then how is it possible? You can imagine how much difficult to construct all these supporting structures, the loading frame in the 1 kilometer sea inside. So to minimize that limitation, what is the new technology? There is a O cell method. This O cell, there is one loading cell which is actually installed in the pile while casting of the pile, which may be located at certain distance from, let's say, bottom or from top. This location is decided by the design team only. What shall be the location to, it is dependent on your what is the skin friction on this portion, and what is the end bearing. This location is mainly decided in the design. So what is done? So if we compare these two tests, here we are applying the load from the top, and in this case the load is applied from this cell, which is being pushed up and pushed downwards. That means load is applied upward as well as downward also. So what is the advantage of that one? So this will eliminate your testing difficulty, let's say in the sea or in the river under the marine condition with your waves are moving, that can eliminate in this condition. And here the advantage is that here in this condition, if I want to conduct the uplift load test, then I need to put an additional, I need to test an additional pile with the uplift load. But in this condition, I am getting both the things, the vertical compression load as well as the uplift load. That advantage we have. And if we compare the such type of monopiles having 2.5 meter diameter, 3 meter diameter, 3.2 meter diameter, you can imagine its size of one room, one bedroom, 3 meters. That kind of piles we are using nowadays, that can be tested with this OCell type of loading test, which is also called as bidirectional load test cell. This is the main new technology which is being used in the field of pile load testing. Moving to the next application, the retaining walls. In retaining walls, we may have different categories. For example, the conventional ones, the RCC wall and the gravity retaining wall. Gravity are mainly your stone or boulders and big size stone retaining walls. The MSC walls, which are the new trends. The Gabion retaining wall, Kavita Annapurna ma'am knows, I think, this well. And you you people must have attended a number of presentations from Dr. Ratnakar Mahajar. So he might have highlighted these two things, MAC wall as well as the Gabion retaining wall and reinforced soil wall also. These are the typical figure which are presented over here. This is a typical gravity retaining wall or RCC retaining wall. What is the role of geotechnical engineering? See, this part is into the contact with the soil. For this soil will exert some extra pressure on the wall. So what would be the pressure and what will be the parameters that as a geotechnical engineer you need to be in a position to give what are the pressures and what are the parameters required by the structural engineer. And then the foundation of this retaining wall is to be designed by the geotechnical engineer only. What should be the minimum size and what should be the allowable bearing capacity, and whether this wall can sustain the settlements and whether the settlements are within the allowable limit. This is to be determined by the geotechnical engineer only. This right side figure is your mechanically stabilized MSC wall only. Here we have panels. On the opposite side, we will be having a geosynthetic or strip reinforcement, which may be metallic or steel strip may be there in some cases. So the complete design of this is totally done by the geotechnical engineer. What would be this the strip length? What should be the grade of this strip? And what should be the properties of this fill which is being in contact with the this reinforcement strip, that has to be defined by the geotechnical engineer only. Moving to the next slide, these are the typical this left hand side is a typical Gabion wall. This can also be a masonry wall as it is a having big section with rock or boulder, something like that. This has to be totally designed by the geotechnical engineer only. This is, if we can say, this is our baby. There is no structural part in this. It has to be totally designed by the geotechnical engineer only. So there are some limitations with the Gabion wall. There are some limitations with the height. If I compare, let's say 2 meter, 3 meter, 4 meter height of Gabion retaining wall with the RCC wall, then definitely this will be cheaper. If as a client, if I need a solution which will be cost effective, if I compare India and abroad, in India mostly the design is governed by what is the cost. That system is to be selected based on the client's requirement, what is the allowable cost and what is the limitation for his total costing, overall budget, what is the overall budget, that has to be considered. So there are number of options for there. If we have to design the retaining wall, we may go for gravity retaining wall, RCC retaining wall, Gabion retaining wall, then reinforced soil walls. That there are number of options in front of us, but how it is to be selected ultimately, that is mainly dominated by your costing. What is the cost? So that has to be compared with each and every system. Then what is the most economical, that we need to propose to the client. Then client will be happy, then that solution can be pushed. So the next option, the next part of the retaining wall is the reinforced soil wall. Here we can see these are the regular similar kind of the Gabion fascia, and behind that there is strills, the geosynthetic strips are there like that. This is the wall in the front, and we can say these may be the geotechnical strips, which are main reinforcing elements. This is the new emerging trend which is being mostly or widely used in the world in the replacement of your RCC walls. If I move to the next challenging application, this is the most challenging part of geotechnical engineering field. If I compare the foundation can be done easily, because there the methodology is well defined and everything is well defined. But the most challenging part is the excavation support system, excavation support system. For example, what is excavation support system? For example, if I want to construct a building over here, I will delete this. If I want, if this is elevation, this is our building I want to construct, and this is your basement. Let's say this is your basement, this part will be your basement level, and here there are number of structures might be there. So you cannot directly construct, you cannot directly excavate this part, because there are chances and there are number of cases that if you excavate directly this part, if you directly excavate this part, so there are chances this building may get collapsed. So to support this excavation, to support this building, we need to put additional elements which are called as the excavation support system. There are mainly widely used are sheet pile walls, the diaphragm walls, and the second pile walls. Let us go into the detail of one by one. First, the sheet pile walls. Here you can see this first image. Here is a typical building is located, and there is a water body here, and we need to support this ground up from collapsing or failure with the help of sheet pile wall. The sheet pile wall here, this green element is your sheet pile wall, which is supporting your this ground from this water, which is separating this one. This is typical actual field image. The sheet pile walls and some construction activities are going on over here to separate this water body from the construction side. Sheet pile wall is inserted, and here one of the typical example here, the your let's say marine condition is there. Here these are the sheet pile walls which are separating your the actual water body from your working zone. The next one is diaphragm wall. What is diaphragm wall? The structure formed in formed and cast in slurry trench. Here what is happening, we will excavate some of the part. For example, here we have road, and here the construction activity is going on. If I excavate directly this part, let's say it may be 10 meter, 4 meter, 5 meter, 6 meter, we cannot directly excavate. If soil is there, it will directly collapse. So there are chances that this existing road will be get collapsed or will get failed. To protect this, we need a geotechnical solution that can be constructing a barrier or supporting excavation supporting system. If even if we do excavation over here, this road will be safe. This is one of the type. Here what is doing, we are excavating the some part of the soil. It is stabilized with a slurry of the bentonite, and we are putting the steel cage. After excavation is complete, then that has to be filled with the trimmy concrete. This is the final the layout of that typical layout after filling the steel cage with a trimmy concrete. This is one of the type of wall. And the next, which is widely used, is second pile wall. Here what is happening, the second pile walls are formed by constructing intersecting reinforced concrete piles. Here different images are presented. Here if you see, if I compare this one, these are the main the where the reinforcement is shown. These are the main two piles, and in between we can directly put only concrete. These are called as the primary second piles, and in between there is a secondary pile to hold these two piles only. So there may be in the reinforcement may be our regular helical reinforcement with vertical bar, then maybe I section with a maybe circular pile. There may not be reinforcement depending on height and depending on the diameter. There are n number of options which can be considered in the field of second pile wall design. These are the typical images presenting the second pile wall configuration. Here you can see this is the construction activities going on the opposite side. There is a road, and these are the installed second pile, the second piles. Here you can see the big building is there, and here your construction is going on. To safeguard this building, you need a very strong supporting system to hold the load of all these building coming from the building, and it should not get collapsed. So the design of all these, we have sophisticated softwares. For example, Wallap is there, other softwares are the Plaxis is there. So that can be done by using those software, and the design properties, for example, the diameter, the spacing. And in some cases, if ground is weak, there we may need to support these piles with the anchors. So these are the anchors. In some cases we may need anchors, and here you can see there are no anchors. So here the ground condition may be better, so they don't require any ground anchors. Moving to the next slide. As explained in the earlier slide, the next application would be the soil nailing and rock anchoring. Most of you have passed through that Katraj highway, or maybe passed through that Mumbai Pune expressway. So in between you may find there are shotcreting is done, and you may find that nailing to if let's say if any work road is proposed over here and the excavation is happened, then that wall has to be supported. And in some cases, if soil is poor, then we may go for soil nailing. Soil nailing is what? Soil nailing or rock anchoring, the steel rod which is placed into the holes, and which is drilled into the wall, and finally it is grouted. It is called as your soil nailing, or in case of rock, it's anchoring. So this is one of the typical ongoing activities for the soil nailing. Here this is the main wall, and in to support the wall, there soil nailing activities are going on. And here you can see the rock anchors are installed for supporting this excavation, the work, construction activities. You may need rock anchors in case of rock is there instead of soils. The next big application, as a geotechnical engineer, we may be having the design of tunnel. This is mainly dealt by the geotechnical engineer. Even though tunneling is required very much design carefulness, there are experts from the geotechnical field only which can do the design of these tunnels. I won't go much into the detail, because this is just, I put this slide to highlight that we can also do the design, because in my career I did not get a chance to work on the tunnel application. So just I have put the images. And the next thing is the mining activities. Here, if you see, these are typical mining activities. So what is the role of geotechnical engineer over here? So let's say this may be 50-meter, 30-meter excavation. So what should be the safe slope? That has to be given by the geotechnical engineer. Even if this slope is not stable, then we may need to provide some additional toe wall like or reinforced wall like kind of thing for this mining activities. So to define this slope, what should be the safe slope, what should be the safe cutting, there are a number of softwares to analyze. For example, slide software is there, geoslope is there, tile run is there, and there are some product based softwares are also there. For example, Maxstars is there, Gavac is there, other softwares are there using which we can do. Resa is there, we can do the designing of these mining slopes, and we can design what will be the safe slope. The next application, the earthwork. Earthwork is what? For example, the new construction of road is going on, and there might be some embankment may there, and there might be some cutting may be there. And for that, what will be the safe slope for the embankment? That has to be proposed by the geotechnical engineer only. For example, if I consider this part here, we need to propose what kind of the safe slope should be there to so that this embankment should not fail after the construction of road. That is part of geotechnical engineering only. What would be the fill material so that it should not cause failure to the pavement? This material should not be clay like kind of thing. That has to be defined by the geotechnical engineer only. The right side image is a typical image which I have taken from the Oman. Here you can see the kind of construction, the kind of slopes we have. Here mostly these are the rock slope, but imagine this height may be more than 100 meters in some cases. That kind of slopes are there. So this needs very much careful design from geotechnical engineer. This requires the coordination between the geotechnical engineer as well as the geologist. So this you can see there are bumps might be there, and there are slopes. This has to be proposed by the geotechnical engineer only. We need to do proper modeling using any available software. We need to check whether that cut is safe by performing the slope stability analysis. If based on the parameters of this ground, if slope is stable, then we can go for that. If the slope is not stable, then we need to propose some remedial measures. For example, example, rock anchoring, nailing, retaining wall construction, some that kind of thing we need to propose. That is also part of the geotechnical engineer. Now the next interesting field is the ground improvement technique, which is nowadays widely used, because if I say consider the Mumbai. So Mumbai, it's totally marshy land, and now the developments are going on the outskirts of the city. So there are marshy lands, though there directly we cannot construct, let's say, uh, any of the structure. There we need proper ground improvement techniques. In some cases we may go for pile foundations also. There are widely, these are the three types of ground improvement techniques which are widely used. The first one is the dynamic compaction, the stone columns are there, and PVDs are the prefabricated vertical in case of cohesive soil. Now let us go one by one. The first one is the dynamic compaction. What is being done over here is that heavy lift crane is there. This is the weight, and this has to be for this weight is to be dropped from a certain height. Then the blows are given onto the ground, and this ground is improved by giving these falling this weight from a certain height. This technique involves repeatedly dropping a large weight from a crane. This, you can see, this is a crane and this is a large weight, and this is the height from which it is being dropped onto the ground. Weight may range from 16 to 170 ton. This weight is dependent on how much improvement you need below this ground level. For example, 10-meter improvement, 20-meter, that weight has that this weight is defined based on that condition, how much improvement you need. The drop height typically varies from 10 to 40 meter. You can imagine 40-meter height. From this height, this weight is being dropped, this 172, let's say 100 tons of weight is being dropped from 40-meter. You can imagine how much it would impact the ground. So done systematically in rectangular or triangular pattern. For example, this in this pattern, if I move, this may be rectangular and may be done in triangular pattern. Each phase can have number of passes. Number of passes means if I complete this row, if I come again, let's say second pass, third pass, then number of repetitions are there. It is done in primary, secondary and tertiary. For example, these are the holes where these are the tampings, the weight is fallen already on these places, and here there is no weight. These are your primary, and in between there may be this may be done in the secondary tamping, and if some place is there, in it may go for the tertiary tamping also. The spacing between impact point depend on what is the depth of your improvement, what is the permeability of soil, and what is the groundwater level. These are the main parameters on which this spacing is mainly defined. So if let's say 20-meter improvement unit, 30-meter, that means what deeper depth, deeper layers are compacted at wider grid spacing. You can imagine, if you keep wider spacing, then that impact will go to the deeper layer. If you keep the shallow spacing, then it will improvement will be done for the shallow layers. So accordingly the spacing is also defined. Then whatever this crater is made, this can be filled with any type of soil, then it can be rolled, or it can then again be compacted. The next one is the stone column. Stone columns are generally are nothing but drilling. These are the vibro flotation. If your any type weak soil is there, where you can do vibration and do the improvement, the vibration, this improvement is done using a drilling rod. This is being pushed inside. There may be a nozzle there. This drilling is first completed at the top. Simultaneously the stones are being pushed inside the hole. Then that drilling rod is being pushed again into the stones. Then it will vibrate, it will compact, it will radially spread your improvement, and finally this is the typical image showing the completed stone column. So what happens, because of this densification, your ground gets improved radially. So in the same as of this spacing, the stone columns are also done in regular spacing. Any type of the stone columns are installed using vibratory probe, generally having a horizontal mode of vibration. Column diameter may vary from 2 to 5 feet depending on the soil condition. What are the prevailing soil condition, whether the soil is very poor or some poor, that is that spacing is, and the column diameter is mainly dependent on that one. Moving to the next one, the prefabricated vertical drains are mainly used for the cohesive soil. If let's say there is a water table and if you want to remove that water, if you want the consolidation settlement to take place earlier, you may go for the prefabricated vertical drain. These are vertical geosynthetic strip having some drainage element inside and wrapped with a geosynthetic element. This can be drilled and pushed to the ground in a vertical manner on a regular interval basis, and it can be taken up to your hard strata, let's say any firm strata, and this is the soft layer. And at the top you may you need to put an embankment, so that because of this your preload embankment, this water is being pushed up. Because here if you can see, this is a firm strata, we can say if there is a rock, then there won't be any drainage, there won't be any drainage will take place in the rock. The water has to move within this soil only. So what we are doing, we are constructing an embankment, we are applying the load, and because of non-drainage element over here, the water is being pushed up and it is being collected at the top. This is one of the kind of the ground improvement technique which is being used in the field of geotechnical engineering. Moving to the next, this is the emerging field, I can say, because when I joined McAfee in 2014, I was mainly dealing with these products, and at that time I found that in India, people, or we can say the contractors or consultants, were not in position to accept the application of the geosynthetic elements, geosynthetic products. But if you find these if you compare with the conventional, you can say the conventional solution, these are very much cheaper and productive solutions by using the geosynthetic products. There are main products are geosynthetic products are geogrids, the geotextile is there, drainage composites are there, geomembrane is there, geosynthetic clay liners are there, geocell is there. All these different products are having unique application. For example, these are the general application by using these materials. We may go for basal reinforcement, the separation, if we want to separate two layers, for example clay or soil, sand, we may go for the geosynthetic element. Drainage application, instead of using your conventional gravel drainage, we may go for the cost effective drainage geosynthetic components also. The pavement reinforcement, which can minimize your cost by minimizing the thickness of the pavement, that can also be used by the geosynthetic reinforcement. The lining solution, in case of ponds, lakes, or maybe landfills may be there, canal may be there, for lining of those elements, the structures, geosynthetic are very productive, we can say, products. Then the next application may be the erosion control, that can also be used by using the geosynthetic the products. This is the image which summarizes all the functions of the geosynthetic. Here the separation, here one of the layer, and if you put a geosynthetic fabric or geosynthetic product in between at the top, these two layers can be separated by using geosynthetic element. The filtration, that can also be, if you put let's say geotextile over here, it can act as a separator also, as well as the filter. The water can pass through from this element, and in some cases you may take the water in radial direction also, in this direction. Reinforcement, in earlier slide you might have seen the about reinforced soil wall, the geosynthetic element was there. That also plays, the reinforcement part is mostly played by the geosynthetic element. The protection in some, let's say, geomembrane, from puncturing those elements, we may put some this protection layer that can also be done. The waterproofing, the drainage composite can also be used. The erosion control, this summarizes all these application in the form of figure. What are the applications? These are widely used for reservoir dam, liquid waste containment, solid waste landfills, canals, lining roads, for the pavement reinforcement, separation layer, rail railroads can also for the application of railroads, the geosynthetic products can also be used. Retaining walls, you have already seen. The erosion control, the tunnels also, there are some products which can be used in the tunnel application, and the drainage system. Let us go product wise, what are the different application. This sheet is presenting the application of geotextile. For example, the protection, this is a typical geomembrane which is placed as a lining material. On the top of it you can place a geotextile layer, so that that geomembrane would be safe from any harmful activities. For example, during the construction activities, this may get punctured. To protect that geomembrane, you may use the geotextile, which can be laid on this top of geomembrane. Drainage and filtering element can also, as a drainage and filtering element can also be used. For roadworks, as a separation layer can also be used. For separating two different layers, geotextile can also be used. Geogrids, this typical image shows in industry there are basic types of geogrids are biaxial geogrid, which has your tensile strength properties in both the direction, and uniaxial geogrid, which are having in one direction the tensile strength properties in one direction. Mainly these are mainly used for the basalt reinforcement, when the poor soil conditions are there. If you want to construct an embankment, for example, here I would like to draw an sketch so that it would be clear to you. This is an embankment. If you want to construct an embankment and this is the ground, let's say this is a clay, soft clay layer is extended up to greater depth, for example 10 meter, 20 meter, 30 meter. Then for this, if you want to go for, let's say, reasonable cost effective ground improvement technology, then this at the below there might be, we can do some replacement using good quality material. For example, sand, or good quality sand with some good let's say fines content, this can be removed, and in between we can place a geogrid layer which will act as a your basalt reinforcement. This is mainly used to minimize the differential settlement which might be occurring because of this embankment and this poor structure. This is called as the application for basalt reinforcement. For the reinforced soil wall and slopes can also be used the geogrids. For the pavement reinforcement, this is a typical geogrid laid on the for the pavement application. For the pavement reinforcement also can be used, the geogrids can also be used. The next application is geomembrane. Basically, geomembrane is your impermeable membrane, we can say, which does not allow water or any material, liquid material, to pass through it. So where we need, for example, canals, lagoons, landfill, water ponds, all the water bodies where we don't want any, let's say, which we want to prevent the water to percolate to the ground, then we can go for the geomembranes. These are typical images showing the application of geomembrane. The next product is geosynthetic clay liner. It's similar to, the applications are similar to geomembrane only, but the advantage over here is it is having self-healing and self-sealing capabilities. For example, if you see this left hand figure, it is sandwiched between two clay layer which is filled with a clay or bentonite. That bentonite is having a unique property that it will self seal or self heal if any nail is passed. So if I compare, if I consider this geomembrane, if any nail pass, then it will be punctured, then that cannot be replaced or repair. So that disadvantage can be come over by using this, using geosynthetic clay liner, because if any nail passes through it, it will self heal or self seal the, because of this bentonite and that geosynthetic clay liner properties. The applications are similar to geomembrane only: lagoons, landfills, water ponds, and canals, to act as a barrier for storing the water or some kind of thing. The drainage composite basically used for the drainage application. These are typical figures which are presented over here. This is RCC retaining wall. On this, in the conventional method, you might have seen there might be a 600 mm or 600 mm, 300 mm gravel filter might have been placed over here. That can be completely eliminated by using this drainage composite material. Here you can just backfill your material, and this will act as a, the water will pass through this geotextile filter, and there will be if I want to present any typical figure, let's say this is outside geotextile, this will be inner geotextile, and in between there will be drainage element. There will be some different geosynthetic element maybe there. So here this is wall. If water passes, if water comes through it, it will pass through geotextile and it will be collected through this, and there will be a pipe installed at the bottom which will be collected, which will collect the water at the end. Here you can see this might be the pipe, I don't know, but this can be collected at somewhere in at regular interval. This can eliminate your regular 600 mm filter. In pavement application also, this can be used for the storing, for minimizing the water seepage. That can also be used in case of ponds and lagoons also. Geocell, these are mainly used for reinforcement and slope protection work. Geocells. Now moving to what are the geotechnical softwares which are being used in the field of geotechnical engineering. The most, we can say, dynamic tool is this one, this Plaxis 2D and 3D, because most of your complicated problems are being analyzed by the Plaxis software only. The tunnel application, the piled embankment, the piled raft, that kind of excavation support system, the complicated problems are being analyzed by using the Plaxis 2D or 3D software. Other software is Geoslope, which is Geoslope, Talrun. These are mainly used for the slope stability analysis. I think in one of the slide I explained what is the importance of the slope stability. So for slope stability, the Geoslope, Talrun, and Slide, these softwares are being used. For the design of your excavation support system, the sheet pile wall, that piling system, these wall-up software is being used. And for the settlement analysis of the shallow foundation, in the earlier slide I explained the importance where the settlement analysis is settle 3 software consider the effect of surrounding footings also. For example, if I want to model let's say 300 footings at a time, that can be done using this settle 3 software. The slide is being widely used for the global stability analysis, flat 2D and 3D. All pile software is there for designing the pile in terms of vertical capacity, lateral capacity. L pile software is there, group pile is software is there. For liquefaction analysis, we have C Lake. For the pavement design, Everstay software is there. These are all standard internationally used software which are used by any MNC. as a geotechnical engineer, you should have knowledge of most of the softwares, because the backbone of geotechnical analysis and design are these softwares only. Now, let us come to what is the role of an geotechnical engineer, let's say in the field of consultancy, or in the field of, let's say, contractorship. So basically, what an geotechnical engineer do, the role vary from consultant to contractor. If I consider, let's say, job of geotechnical engineer in consultant field, what is his role? Let's say if any building project comes, or let's say any, if I consider let's say VBSL project only, Warsaw Bandar Ceiling project, what I initially do, I will go through the required document, and first the main backbone which I need to do is we need to prepare the ground investigation, that is subsurface investigation. What should be the boreholes, what should be the depth of borehole, uh, what should be the location, and what kind of test we need to provide. That is the first and main foremost job of the geotechnical engineer. Planning the subsurface investigation layout, planning, preparing the specifications, BOQ, which is to be floated for inviting the contractor, for inviting the contract, and supervision in some cases also. This, I want to highlight that the depth of borehole, let's say, or the location, number of boreholes, these are mainly defined by the codes, the respective codes which country has. For example, these are the listed codes. For example, ASTO, if I consider America, USA, then ASTO will be dominated by ASTO code will dominate the design. If I consider European countries, then Euro code, UK, consider British code, Singapore code, Syria codes are there. If I consider India, then IS code and IRC codes are being widely followed for defining, for preparing the geotechnical investigation layout. Then once we propose the geotechnical investigation, what is the next role? Sorry, the contractor will do the site investigation, he will submit the reports. What the next role will be, reviewing that factual reports. If there are any comments from our side, then we need to put it to the contractor. He will amend the report as per our observation, and he will send the final copy to us. Once that comes, the next important task is the preparation of GIR, which is called as the geotechnical interpretive report. For any project, the main submission from the geotechnical department is the geotechnical interpretive report, in which what we will be doing, the ground investigation, the factual ground investigation reports which the contractor has provided to us, we will analyze each and every parameter. We will provide the design parameters, what would be the design, let's say C5 UCS, what should be the RQD, what should be the TCR, all those kind of things we will define for each and every different material. And in the GIR, we need to provide what would be the self-bearing capacity, what will be the pile capacity, what will be the earthwork slope, and what will be the pile testing, and all those things will be part of your geotechnical interpretive report. The main task of the geotechnical engineer as a concluding point is the preparation of the GIR. Once we receive, once we prepare, once we define the design parameters, then next comes the coordination with the different departments. For example, if any building is being designed, if a structural engineer wants to design the foundation, then he reaches to us, he asks us what is the bearing capacity, what would be the settlement of the foundation. It is like structure and geotech interaction. It's coordination between structure and geotech. He will give load to us, we will analyze using any software, we will find the bearing capacity, and we will give it to the structural engineer. Or in case of bridges, we will do mainly the pile design. All those things will be in coordination with the structure and bridge team. The next task, once the design is completed, the next task is to prepare the tender documents. The tender documents may be the specification for earthwork, the specification for the piling works, and the method of measurement, which is to be floated as a contract document to invite the contractor to bid for the project. That is also part of the geotechnical engineer. In case of river or marine bridges, what would be the foundation design? That is part of the geotechnical design only. In case of excavation support, if there are existing, if we are going for deeper excavation, buildings, basement, so we need to perform the excavation support analysis. We need to propose the suitable excavation support system. In case the slopes are there, for example, that Oman slide, for that case we need to perform the slope stability and we need to propose what would be the suitable solution. Pavement design, what would be the thickness of base layer, sub base layer, that can also be defined by the geotechnical engineer. MSc wall design, this is the totally designed by the geotechnical engineer. Ground improvement, if any ground improvement is there, we need to do the ground improvement also. The numerical analysis, as I stated, these all softwares are mainly based on your structure and geotech interaction. We can say soil structure interaction, that has to be done. Then pile load test, if piles are there, we need to define the pile load test. What will be the method of, what will be the method we will be using for that, what will be the specification, if required supervision is to be done by the geotechnical engineering also. The enabling works, which may be temporary, permanent, for example sheet pile wall, diaphragm wall, second pile walls if may required, that is to be designed and proposed by the geotechnical engineer. Retaining wall foundation, the design parameters which are required for the structural design, that also to be defined by the geotechnical engineer. For the tunnel, geotechnical engineer plays important role. The tunnel design is to be mainly done by the geotechnical engineer. All these designs, it varies from code to code. As a BE student or diploma student, you might have read the books, but in reality the design is, what books provide it, they provide the basic knowledge. For example, for the pile design, the pile design is mainly consider your skin friction and end bearing, but how it is to be calculated, it is defined by the different codes. There may be some additional factors. If I am working in India, then I need to abide by the Indian codes, that is IS and IRC. If I am working for, let's say, UK projects, then I need to use the British standard codes, Euro codes. The your planning, the complete design is mainly governed by the local or country codes, which are mainly referred by the geotechnical engineer while deciding the while working on the geotechnical design. The next, now moving to what are the opportunities in Indian market as a geotechnical engineer. In India, we have lot of opportunities, but if I compare, let's say, last 3 4 5 years, then I found that there are number of multinational companies have come in India where the geotechnical requirement is there. For example, the Jacobs, which I am working on, Dar Al Hansa, I was part of that. Ecom is the biggest US based company which is also have presence in India. Ramol is there, Stantec is there, in Pune we have Stantec. Black and Witch, it is also US based company. WSP Global, Covey is there. Atkins, Arup, McAfee, Strata, GTA, Tinsar, all these are MNCs where you can be part of the geotechnical team. If I consider the local domestic, L&T is the biggest contractor where the geotechnical requirement is there. Tata Metro, Tata have number of subsidiaries there also. You may take a part. HCC is there. I have not listed all the local companies, but there are n number of companies. The local site investigation contractors are there. If I consider Pune, then Soiltech is there. If I go to Mumbai, then DBM, Renukan, there are number of local site investigation companies are there. That there also you can apply for the job, or you can get an opportunity to work as a geotechnical engineer. Once you complete your post graduation in the geotechnical engineering, then you may go to the one of these companies. If you have any if you want good exposure, you may join any of the MNCs, but it needs some some experience, or let's say some extracurricular activities, because MNC scrutinize very well to the employee while recruiting the employee. You should be very much confident. That confidence is being checked in the while interviewing. Your capabilities, your technical knowledge, your smartness, all those things are being checked by all the MNCs while interviewing, while recruiting any employer. Now let us have a small video of the coastal road. This is a coastal road project which is being executed in the Mumbai. I feel very pride to be part of these two, the Coastal Road project and the Warsaw Bandra, which are iconic. You can also be part of such kind of, let's say, structures. If you go for post graduation, you can become structural engineer, geotechnical engineer. If you go for post graduation, you can become a designer. Then you can do also such kind of design of such kind of structures. You can also feel pride that you are part of this national important structure. So unfortunately, I wanted to present. Fortunately, I wanted to present the case studies of these two bridges, but because of limitations and some restrictions from the company, because some legal restrictions, I cannot present the case studies of these two, Warsaw Bandra Ceiling and the Coastal Road project. I apologize for that one. Here I conclude my presentation. Any questions, any comments from anybody? Kavita ma'am, Vikas Patil sir.
Hello.
Yeah, hi sir.
Hi, Shardhajan. I'm really very happy. I'm really excited to see your presentation. I appeal you that you are so young and so valuable person for the society at large. The way you contributed, the way you presented, really hats off to you. I'm really happy for your presentation. An excellent presentation, definitely inspiring to the all youngsters. So I appeal that you be a part of our team and always contribute to the society for the benefit and inspire the people to our field. Really, I'm really grateful to you.
Thank you sir.
Thank you, sir, for the kind informative session. Sir has given exact overview of geotechnical engineering, how water plays an important role in the structure. He shared his experience with the help of his site photos, informed about the liabilities and the field test. What are the different geotechnical applications? He elaborated the new phrase in such as a monopile foundation, bidirectional load test, diaphragm wall, and a tunneling, etc. He also added the knowledge of the different softwares. I may say that all participants have enriched with this expert session, and I hope that this session will prove beneficial for all the participants. So we will proceed for the question answer session. Now the chat box is enabled. You can put your questions in the chat box.
We got a question from Pratiksha Khairmode. What is the application of geosynthetic clay line?
Geosynthetic clay liner is similar to geomembrane only. Okay, so basically it acts as a membrane which can act as a barrier for which can act as a barrier between water body and the ground, so that the water percolation should not take place. That is the main aim of the geomembrane or geosynthetic clay liner. So it is the main aim of the GCL is act as a barrier between water body and the ground. That is the main function of the geosynthetic clay liner.
Yes, Shahnawaz, very nice presentation, and you have covered many aspects. Actually, what are the prospects of geotechnical engineers with the current prestigious projects which the nation has taken up. Apart from that, even the technical aspects and the emerging trends, that is very nicely you have covered the geosynthetics also, of course, in the given time limit. So look forward for more specific contribution, and with whatever confidentiality you have to keep it from the project point of view. In the next presentations, you can come up with the project specific PPTs also within the limit.
Yes, sure.
Thank you, Shahnawaz. Thank you very much. Yes, question answer session can continue.
We have got a question from Sunil Kumar. Any thumb rule for the embedded depth for the sheet pile walls based on the depth of excavation in sands and clay?
Yeah, so it's like while designing, it's a iterative process. While initial design, you can consider 0.5 h or equal to h. you can consider and you can perform the analysis. As once you perform the analysis, you can change, you can plus, you can add, or you can deduct the length or depth of the excavation support system. That can be done. You can initiate with the, let's say, 0.5 h or 0.75 h of the total height as an embedment.
I think Sachin Deshpande is requesting to be unmuted. He has some question.
Yeah, he has question. Now we are working on soil stabilization project under guidance of Dr. Raviraj Sote, sir. I have some questions related that. Please share your contact or give me permission. I see on soil stabilization, I did not work much, because you can do one thing. You can send me the question through Chaitanya Shedgar. He will compile and forward me all the questions, and I will take help from other colleagues who are expert and who already worked in that field, and I can compile and send the answers to Chaitanya Shedgar, and he can finally distribute to the concerned person.
Okay, sir. Thank you, sir.
Yeah, that can be done. Yeah.
Sir, we have got a question.
Yeah.
Scope of a seismic factor in geotechnical design, whether it is part of geotechnical or structure.
It's part of both the things. As a geotechnical engineer, it is required mainly for the liquefaction analysis, and for structural design it plays an important role. For both the things, that seismic factor plays an important role. Even the magnitude of the earthquake also, that plays an important role in both structure as well as geotech part.
Sir, we have another question from Pratik Verma. Sir, in our project, we are working for analysis of retaining wall. Are there any software available for seismic analysis?
Yeah, that can be used, but it depends what analysis you are doing. If you are going for regular conventional retaining wall, if you are going for, let's say, RCC design, then I think the Excel sheets are there in the market, and available tools are there, which that the seismic analysis can also be considered. But if you are going for slope stability analysis of retaining wall, then in the softwares you can put the earthquake, that factor, magnitude, and that factor can be put as per the zone which is defined in the IS code. That can be put, and the analysis can be performed for the seismic analysis also. That can be done by using the available software. That can be done.
Yes, sir. Actually, we are doing a we have done the pseudo static approach of calculating the seismic forces. I was wondering if there any softwares are available for the same for to cross check my calculations.
I need to check with the structural colleagues. So what can you do? You just write your question and send it for the compilation. I will ask my colleague who are the structural designer, and I will come back to your answer, to your question.
Thank you, sir. Thank you, all the participants. Dear participants, due to time constraint, we are sharing our mail ID. You can mail your questions to this mail ID, and all the questions will be answered and sent to all the participants. Thank you.
Thank you. At the outset, I would like to present my sincere thanks to the IGS Pune chapter, the organizer, the office bearers, Kavita ma'am, Vikas Patil sir, and all the office bearers, especially my friend Chaitanya Shedgar, who has given me opportunity to present presentation at this platform. Thank you all. Thank you again. And if you have any question, you can ask. You can ask your colleague, and you can ask to Chaitanya Shedgar. He will forward that to me, and I can respond to that one with the help of me or my other colleagues also. Thank you. Thank you all.
Thank you, sir. Actually, we have shared mail ID in the chat box for the additional questions, and which will be answered by you only. and we will be forwarding to all the participants.
Yeah.
Thank you, sir.
Thank you.
Engineer AP Singh, sir, Executive Committee Member, IGS main body, is present over here with us from the morning session. And Dr. Sorte, Executive Committee Member, IGS Pune chapter, and HOD Civil Department PVPIT is also with us in this session. So I appeal both of them, if they want to share their views here, then please, they are welcome. Iyer ma'am.
Yes, ma'am.
Iyer ma'am, if anybody from IGS body is willing to share their views, they are welcome. Thank you.
Namaste, madam. Dr. Sorte here.
Yes, sir. Yes, sir. Please go ahead.
Mulani sir, it was a fantastic presentation from you. Actually, I was with you from retaining wall, that particular slide. Actually, I was having one assignment, so I was doing that. But after that, I was there for your entire session. It was fantastically arranged by BSCOER. So I must congratulate the HOD of Civil Department, Karale sir, and his team, along with all the IGS student chapter members of BSCOER. Such type of lectures actually need to be conducted every now and then. Generally, थोडं मराठीत बोलतो की आपले विद्यार्थी जे आहेत जिओटेक्निकल इंजिनिअरिंगचे बऱ्याचदा असं होतं की जिओटेक्निकल इंजिनिअरिंग हा त्यांना टफ जातो किंवा त्यांना आवडता सब्जेक्ट राहत नाही आणि जनरली तो असा म्हटलं जातं की तो कोण शिकवतो त्याच्यावरती डिपेंड करतो. Unfortunately or unfortunately, there are very less colleges which are there who are offering the ME or MTech degree in the field of geotechnical engineering.
Yes, correct, sir.
So such a type of lectures from Mulani sir, and that too explaining in such a depth. Actually, you have touched all those points which are required to be touched. In addition to that, I think you have spoken like a national responsibility or national importance of the structures which are generally constructed nowadays, like Coastal Road project or Warsaw Bandra link project. So such type of projects needs to be taken as a case study for the students, and every now and then such type of guest lectures or expert lectures needs to be organized by the college, as well as such type of student chapters should be active enough to arrange such type of lectures. So I must congratulate all the members of student chapter of IGS. We are supposed to do a lot of work. So in consultation with Karale sir, I will visit your campus. I will discuss all those things with your student chapter in charge, the faculty advisor, and that will be a great thing in future. Thank you, Mulani sir from IGS team, Chairman sir, and Secretary madam, Joint Secretary madam, Iyer madam. I thank from bottom of my heart. Thank you.
Thank you, sir. You are welcome, most welcome, sir. In continuation, मी बोलायचं आहे की जिओटेक्निकल फील्ड हे ऍक्च्युली व्हेरी रेअर फील्ड आहे. Okay, the interest has to come from the student only. If he has interest in the design, he can become a part of such marvelous structures, not nationally as well as internationally also. You can be part of any of the structure. If you join MNC, you will get very good exposure in the field of geotechnical engineering. The students must develop their interest, because geotechnical field is very interesting. If you compare with the structural field and other field, they are also very good, I can say, but the geotechnical is very more challenging than the structural field, I can say. So student should take part or develop the, let's say, interest in the geotechnical engineering during their graduation. Also I think there is foundation engineering subject during the graduation. I think one subject might be there in the diploma also. So from there only they can develop the interest and they can become a geotechnical engineer if they develop the interest in the design of foundation or geotechnical engineering.
Now I request Dr. G.A. Hinge sir, Principal of Bhurabai Sawant College of Engineering and Research, Nare, Pune.
Yes, thank you. Am I audible?
Yes, sir.
Yes, yes. Engineer Samadhya, the president of IGS India level. Engineer AP Singh, executive committee member IGS. Engineer Annapurni Iyer madam, joint secretary IGS. And engineer Vikas Patil sir, who is chairman of IGS Pune chapter, and he is also my friend, guide, and philosopher. Then today's speaker, engineer Shahnawaz, Mulani, Dr. Sorte, some other teachers and students who have joined from different organizations. At the outset, I welcome you all once again on behalf of TSSM, Bhurabai Sawant College of Engineering and Research. If Vikas Patil sir knows, we have established IGS chapter, student chapter at our institute before lockdown, but somehow due to the pandemic situation, the activities have been stuck. But now I am very happy to see that the civil engineering department of our college, they have taken the initiative, and once again we can say we have re-established this chapter with this lecture. IGS has been instrumental since long in organizing such activities and creating awareness among students about the geotechnical engineering. And especially I would like to thank Vikas Patil sir also, because he is very keen to not only establishing the chapter, but the chapter is also live because of him. And about today's session, even though engineer Shahnawaz Mulani, he is a young engineer, but I had witnessed the complete presentation of him, and I am very happy because the students, they must have obtained lot of opportunities, not only to see the challenges and problems in the field, but there are many opportunities also which they can definitely grab after completing their graduation. I remember the definition of civil engineering written in the Dictionary of Civil Engineering by Mr. James Scott. He is defining civil engineering in such a manner that it is such a vast field of engineering that in a single life, one person cannot do specialization in more than 2 subjects. And definitely after watching today's presentation, the viewers must have grabbed this view that yes, definitely, even if we talk of only geotechnical engineering, there is ample scope and you can spare even your complete life in this field just by identifying different problems and solving those problems. And such type of sessions are really helpful to bridge the gap between industry and academia. And all the industry stalwarts, they have joined this session today. So I am very much thankful to them. And I request Patil sir to, yes, I request Patil sir to have faith in us, and definitely in days to come, we will arrange not only sessions, but also the site visits. Yes, sir.
Yeah, before you conclude, I think I would like to appreciate, Inge sir, I really strongly acknowledge in the morning only that you people, Sumoto have organized this today's event. Is the first event of the student chapter organized by Sumoto, by the particular student chapter. It's really, we strongly acknowledge that. Secondly, I know that you are the instrumental for that. I mean, you are really driven very well. Secondly, what I noted, the way it was presented, the starting of your this today's session, you really remember all the photographs and all the sessions which we arranged in your organization, in the institute. So really, it was giving me the back memories. I mean, really, I'm really happy for that. Your staff coordinator, I think, Kirti Bhosle madam, strongly acknowledge her contribution in this regard. I think she has put her pen in this. And sir, really great. We'll really see the great future in coming days. Yes. Our civil engineers should not be beggars. They should not stand in the market. It's my demand that as people, please, you just convert your career in the academy, in the technical side. Don't be a normal contractor and takeover and all that. There is a great scope in the market where by your technology, by your own, confidence, technical confidence, you can really demand the market access. But today, what I'm finding that boys are not getting that confidence and that courage to demand that yes, I can do this work, I can do that work. So there is a great scope as far as geotechnical is concerned. I appeal not only that I am making a commitment, just talking over here, but my family, I have converted, I diverted my son is doing MS in geotechnical only, and tomorrow he's going to do PhD. Though he has to come in the business, only, but it is that he has to pursue PhD also. Tomorrow he should not shortfall. After 20 years, 25 years, he should not feel that my papa didn't advise me, didn't give me that direction, that I'm falling short of the doctorate degree now. So Baba, you do everything. Complete your graduation, complete your post-graduation, complete your doctorate, and then you enter in the market as a businessman.
Yes.
And that too in a technique with the technical know. So I'm really grateful, sir. Inge sir, it is your great initiative. I expect that many such programs, at least in a year time, 5 to 6 sessions should be conducted in the institute, and we are there to support you, sir.
Yes, yes. Sir.
Today's Shahnawaz presentation is really appealing. Such a young personality is giving such a good insights, really appealing to me. Thank you. You identified the right person, and really grateful to all people, those who are participant and those who are really organized this in a systematic way. Great.
Yes.
Thank you so much, sir.
Yes. Before I wind up, I would like to mention few names. Mr. Chaitanya Shetgar, who is head of Diploma College, Dr. Karale, and all the students and faculty members who are actively involved in this program. Thank you. Over to Dr. Karale.
It's Madam.
Thank you, sir. Now I request R.S. Karale, sir, Head of Department, for delivering vote of thanks.
Thank you very much, Dr. Inge sir. As a vote of thanks, it's my pleasure once again to have such an eminent personality, Engineer Shahnawaz Mulani, who has, in spite of his busy schedule, he has spared his time, and from a remote place, he is able to connect to hundreds of students who may be located at different places. So, and even with a proper way of communicating the students and enlightening the students with the different aspects of geotechnical engineering has really made the students and the civil engineering fraternity that yes, there is a wide scope in civil engineering, and yes, together we can build up and move further. So thanks very much, Mulani sir. We also thank IGS dignitaries, Chairman Engineer Vikas Patil sir. Thank you very much, sir, for sparing your time. We have seen you interacting with our students before the lockdown. So our students were very much eager to see you further. And now with a new beginning, we will certainly have plans to conduct offline sessions, wherein in addition to the regular guest sessions, we'll also plan for some faculty development programs also. Now, I am also thankful to Joint Secretary Anna Purni Iyer Madam for sparing her valuable time and supporting this program. I thank all the participants who were right from the beginning. They were connected with us, and yes, certainly we'll share some of the informative slides to them through proper channel. The video is also available with us. The presentations is available with us. It will be shared to us. The questions were thank for the questions, because that shows that yes, they were interactive and they were really listening the sessions. And very soon we'll be connecting to them through offline mode also. We'll be very much happy to see them all in this campus. So all are invited. So even all the sessions and these PPTs videos will also be available through our YouTube links. We'll be sharing to the students. I thank the principals, head of the departments of engineering and polytechnic institutes from Pune universities and other universities, and also from our group JSPM and TSSM group of institutes located in Tathawade, Baudan, Hadapsar, Wagoli campuses, who have supported us through various means. And really this shows the strength of the group of JSPM and TSSM. So we are once again thank to all the principals and head of the departments. I personally and on behalf of Department of Civil Engineering thank our director Rushraj Sawant sir, who is a constant source of inspiration to us, and he is helpful and very much motivating to us to conduct a lot of activities in the campus. So thank you very much, sir. I thank our principal, Dr. G.A. Hinge, sir, who always supports us and helps us in arranging such programs. So thank you very much, sir. I thank Principal of Polytechnic Institute, Kande, sir, and his HOD members, Shedgar, sir, and his team members for supporting this event. I thank uh, all the students here, because this is the first time after the lockdown where we have our students engaging the programs. Earlier we were just interacting with them through online mode, but now we have the students with us, and they have just supported through this activity by sharing their time, and also they were really they find it very useful, all the sessions, and this is a good platform where they can interact with the various dignitaries, and certainly we'll look forward that how we can arrange some site visits or any internship programs, because nowadays internship is a compulsory event. So how we can bridge the gap between the industries and the institutes by arranging such industry institute interaction programs through internship or through project activities in this area of geotechnical engineering. I also thank all the non-teaching staff of the department and the institute for supporting us and providing us the facilities. Thank you one and all.
All the participants, please on your video, we have to take a snapshot of it. With respect to all the dignitaries, I convey that this session is concluded.